All right, let me get the. Oh, it would help if I hook this up. All right. And then this might be going back to our discussion before class on the FE exam. This might be a hot take, but I think the FE was harder.
Is it just because you didn't know as much?
No, I think the FE covered a broader cross-section of material. So I think my brain was going, I mean, I had to do chemistry and thermo and circuits and all this, and, it felt like this, like there's no one question that was incredibly difficult. There was just a ton of them over, an 8-hour period. So I just felt like a truck hit me after taking the FE. And when it came to the PE, I think because the range was narrower, so. And I felt that the FE was far more technical, whereas the PE seemed to be very specification based. Like what are the rules here and so on and so forth. So, I'm not saying it wasn't more or less important. Just I don't know. Just didn't feel as tiring. So, okay. I'm still working on your project. Again, my goal is next week. My be-all, end-all day to get the project back to you, and I might do this by design, is to give it back to you next Friday, because next Friday is when we start masthand. And you can't do submittal 2 without masthand. In fact, you can't really even start it without masthand. So as long as I get it back to you by then, that'll be good. But Monday, we have ourselves a celebration, right? We are celebrating again. A couple things about the housekeeping items. So did everybody get masthand installed? Everybody, hopefully it wasn't all that challenging. I have no more homework assignments for you until next Friday, and then that homework assignment is not due until the following Wednesday. Unless you want me to come up with one. I'm getting discussion from the class when I start coming up with additional homework. But yeah, we're going to take it easy a little bit on the homework. So instead of giving you 2 separate assignments on masthand, I'm just going to give you one with 2 problems. When we get to masthand, what you'll find is that, once you know how to run it, you know how to run it. There are slight differences between, there are things that you need to know, like how do you use the pre-populated set of sections in masthand versus creating your own? How do you plot certain diagrams? How do you apply loads to joints as opposed to loads to members? Or I'll start using the terms nodes and elements and what have you. But once you figure all that stuff out, it's a pretty straightforward enterprise. And I think you'll find that you'll probably spend more time on, it'll be homework 7. You'll spend more time on homework 7 sort of formatting the submission as opposed to actually doing the work. It'll be pretty quick. So, and we'll have in-class examples on all that. So, but that's not our topic for today. Our topic for today is the exam review. Let's talk about the exam. Okay, so let me pull this up. Let's talk about this exam. So first off, I will say that the exam format will be pretty much the same format as the last exam. There are a couple things that I think are worth mentioning. Number one, I think that we would all agree that a straight edge would be very useful on this exam for the purposes of constructing shear and moment diagrams. Okay, I do think that would be a very worthwhile addition to what you bring on Monday. The other thing I'll tell you a little bit about the format. So as an example, let's say I have you construct a shear and moment diagram. I will give you space to do that. Like the guidelines and then the lines this way, because is that really a test of your ability to construct a shear and moment diagram, whether you can draw a horizontal line and put a V next to it, or draw another one and put an M next to it. So I'll give you some space in that regard so that you're not wasting your time on that. I have the same rules as the formula sheet for the last one. I don't really care what you put on it as long as you sort of make it yourself and that you don't put a full start to finish worked out example on it. You can put snippets of examples and what have you, and I'll give you some freedom to format that formula sheet however you want. I just want you to make it. Same rules as last time. Let's talk about what's on the exam, and the star of the show for the exam are shear and moment diagrams and deflections. Now, because of the nature of what we're doing in here, I do have to mention that you got to compute support reactions too, okay? I don't mean for this exam to be a repeat of exam 1, okay? So I'm not, like, if you remember on exam 1, I gave you a pretty challenging support reactions problem, okay? I'm not going to do that type of exercise on exam 2, but you cannot do a lot of these analyses without the presence of reactions. In some instances, I may give you the reactions and just have you move from there. Some instances, you may have to compute them. But I don't want the computation of support reactions for you to think that that's totally not fair game, because it is. It's part of the analysis. But the star of the show is deflections and shear and moment diagrams. So on the topic of shear and moment diagrams, you really need to be able to do 3 things. You need to be able to determine the internal and shear and moment at any given point. And so you can do that 2 ways. You can either cut a section at the point in question and write equations of equilibrium, or you can construct the shear and moment diagram and just say, what is the shear here? What is the moment here? And if the shear and moment diagrams are relatively linear and whatnot, then you should be able to do that. You do need to be able to formulate functions, specifically shear functions and moment functions for beams and frames. So that's the algebra portion of it. And you do need to be able to draw them. You actually need to be able to construct the shear and moment diagrams, most likely using the graphical approach that we've been using this whole time. As for deflections, yes, you do need to be able to compute deflections in structures, so you need to be able to analyze real structures and virtual structures. And so you need to be able to compute both displacements and rotations, and you need to be able to consider both axial and flexural deformations as appropriate. And so that's sort of more on the behavioral aspect. Like if you remember when we were doing frames, we found that axial deformations really didn't matter all that much, that they didn't really affect the answer all that much. The rest of this is just sort of some greatest hits over the past since the start of the semester. I did put stuff here on supports and incline loads, and honestly, I just copied a lot of this from exam 1. I'm not going to get hyper inventive again on computing support reactions, but again, you do need to be able to do it. You do need to understand that when you cut a section through a hinge, there is no internal moment. You do need to be able to understand the derived relationship between loads, shears, and moments, and that is that if you have the loads and you integrate them, that results in the shear diagram, and if you have the shears and you integrate them, that results in the moment diagram. You do need to understand that, this is our graphical approach, and I mean, we've been using this slide. I mean, a lot of times we sort of breezed past it, but we really didn't use this slide like for the past 3 weeks. We were saying that if we're looking at the relationship between load and shear, at any given point, the slope on the shear diagram equals whatever the load is right up above. And then between any 2 points, the change in shear is equal to however much load there was between those 2 points. So for example, if we were looking at a beam with a series of point loads, between those point loads, there's no load, so the slope of the shear diagram was flat. That's why we got that stair-step pattern on shear diagrams, which is point loads. And we can make the same determination between shears and moments. That at any given point, the slope of the shear diagram is equal to slope of the moment diagram is equal to the shear, and then between any 2 points, the change in moment is equal to the area of the shear diagram. We have our expression for virtual work, and so this is where I said we're going to need to compute both real and virtual moment functions. We do need to be able to do that in order to be able to integrate. And so we will have the real moment function, the virtual moment function, and then EI, and we will integrate accordingly. Don't forget your unit conversion factors here, which 1728 for deflections, 144 times 180 over pi for rotations, and just conduct accordingly. And I mean, I really don't have anything else to say. That's the exam. So that's it. So, like I said, for all exam review sessions, this is your time more than it is mine. This is your time. Any questions that you have, any concerns that you have, anything that's worrying you about the celebration on Monday, I want to be able to address. So with that, the floor is yours. Yes?
When you mentioned having snippets of like problems or whatever, is that like, are we still not allowed to have numerical values in those snippets?
I don't have a problem with that. I don't. What I think would be bad is to waste time on a formula sheet and just literally regurgitating a whole problem. What I'm sort of not looking for on your formula sheets is regurgitation.
Gotcha.
That's what I'm looking for. Okay, because here's the thing. I think that if you do not just copy paste and you actually synthesize your thoughts and formulate them onto a formula sheet, by the time you're taking the exam, you'd be surprised how you're not looking at it. And you're doing better on the exam because that exercise put the thoughts in your head. That's what I'm saying. So it's sort of my way of forcing you to study. I'm sorry. It's like I want you to learn or something. It's crazy. Yes?
We worked through last night's homework.
We work 6-4?
Yeah.
We can take a look at it. We can take a look at it. Here's what I'm going to do. I'm going to pause the recording. That's what I'm going to do. All right, for those of you that missed that section of the recording, I went through all the solutions of the exam. That was a joke, not very funny one. No, but I know the exam, you have 50 minutes. I take that into account. And I'm sure that you all don't believe me. I don't think this exam is a time crunch. I'm sure some of you are like, how? So I'll tell you this. I do think, I'm teaching statics this semester, and they're asking me some really good pointed questions about the exams. And they're not asking me about, can you go through a cross product on problem 3? They're asking me, like, what do you think's the hardest part on the exam? I'm like, well, that's a good question. And I'm going to give you a similar direct answer. I think the hardest part on this exam is algebra. I mean it. I mean it. I think the algebra is the hardest part. But the other thing I'll say is that there is a graphical correlation. Okay? Don't ignore it. Okay? Don't ignore it. Like you should know, for example, let's take some of the very first structural analysis moment diagrams that we did, like distributed loads. Let's talk about distributed loads. The load is constant. The shear is linear. And the moment is quadratic. So you should know that if you have to write an equation for a moment, or if you have to write a moment equation for a beam that has a distributed load, you should have an x squared term in there. You know what I mean? And if it's not, if you're doing the math and you don't have an x squared term, something's wrong, So, and you can use that knowledge to guide what you're doing. But yeah, I do think that's the hardest part, is the algebra. The calculus, I think the calculus is the easy part. Hot take, I think algebra is harder than calculus. No.
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 I could do algebra in 7th grade. I still can't do this.
Algebra is when math starts to get abstract.
This is the easy calculus.
And I have found students, listen, I have been an engineering professor for over 10 years. I'm telling you, my students tend to have a harder time with the algebra on my exams than they do the calculus.
Who the hell taught their calculus?
Let me ask you a question, Mr. Cupboard. That integral that we did, I mean, we had an integral of this.
Yeah.
I mean, that's what we're doing.
Yeah.
You know what's crazy? You know what I remember from Calc 1 and 2? I remember that Dr.
No names.
You know, I just, no names, I'll just say this.
No language.
The professors that I had were G's, alright? They did partial credit, and they were like, hey, you know what? I'm gonna let this guy do his thing, you're gonna pass. Alright, that's what I remember from Calc. I went, I did my job, I got out. That was it.
No cap?
The day you say on the dead homies is the day that I'll roll over my grave.
Do it right now.
Do what?
I'm having a bad day. Will you please just say that loud?
What, no cap?
No.
I don't know what you're talking about.
You said to say on the dead homies.
Go ahead. Please.
You want me to say? On the dead homies?
You can turn off the recording.
Sponsorship. You're gonna lose the sponsorship. You can't do it. We need to reach out a little.
No video, this video is not brought to you by HelloFresh or?
Reach out.
Read Shadow Winds.
On the dead homies. I'm not going to pass this.
Oh, God. I love my job.
It keeps you young.
No, I mean, here's, in all seriousness, I think that this is easy. I think getting to this is the difficult part. Okay? That's the challenge on this exam. And my answer to you is this is your ace in the hole, is to graphically construct it. Okay? Or at a minimum to know, okay, let's take this virtual structure, okay? I know that I've got two functions, a line, a constant, independent of all that x minus 8 stuff, okay? That's what I'm saying, all right? And that if your function doesn't just look right, okay, that go to this. That's what I'm saying. That's what I'm saying. What?
I'm waiting for you to say it. A banger right there.
Oh, God. Something tells me I don't want to be, my YouTube channel get canceled or something. So.
I will gladly go on WSAZ and say on the deadlifts, I love this school.
Let me ask you this. Is there anything that is particularly concerning you about the exam on Monday that we haven't discussed?
We will have multiple functions, mx, as the exam.
Possibly.
Is that a yes?
It's a possibly.
That's a yes.
I'm still worried about the time.
What?
I don't know how to convey to you that I genuinely don't think time is a problem without. All right, I'll say it like this. I was able to do this exam. Remember how I told you I use a rule of 3? I was able to do this one faster.
You must have a degree in this.
It's almost like you have a history with this material. I bet you've never struggled on a problem. Like you make these exams and you're like, this is so nice. You just keep
I
going.
make mistakes in class all the time.
Yeah, but I don't know.
Do you factor in time for
Making a
crying?
mistake and struggling.
Do I factor in time for crying?
Yes.
Now that one I don't do, but I do use a factor of safety of 3. I mean, that is meant to account for uncertainties. I would lump that in there.
No, I read a question and I need a minute to cry about it before I can even get into it.
I love my job. I mean, have I ever really been one of those professors that enjoys the misery of his students? You had me multiple times. You know at this point. All right. All right. We're all sort of winding down. So last chance. Going once.
Do you think it's better for us to start with that or cutting a section? Okay.
That's a good question. I think it depends on. This is the answer I'll give you. That's a good question, and I want to give you a detailed answer to that. So his question was, do I think it's better to start this way or to start with cutting a section? I think that if you have a problem, I think it was maybe the first problem or the second problem on homework 6.2 where you needed multiple moment functions, like one from here to here, one from here to here, one from here to here. I think that the graphical moment diagram can help you best, like for the one in the middle, you know, because that's where the algebra gets the nastiest. But then you plot it and you're like, wait, it's a line, and it's a line from here to here, and I already know the slope of that line. You see what I mean? But for the ones on the ends, probably not. It would probably just cut the section. That would be Dr. Mike's tips and tricks. You know, don't take that as like telling you that's how you're supposed to do it. That's just my advice. So, going once, going twice. 10 a.m.
How do I know the multiple function? How do I figure out if I need?
All right. So the answer to that is. Let's see. I think it was in one of our earlier Shear and Moment presentations.
Yeah.
Where, hold on, let me find it. Sorry. Maybe it was this one. I think it was this one. Maybe it was. Yeah, it was right here. So, again, this is what I think that you should do. I think this is the easiest way to figure that out, is to literally take a sheet of paper, start here, and just start working your way over. So, like, watch. Triangle, 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 triangle. Boom! Oh, something's different. Right? Okay? Nothing's different, nothing's different, nothing's different, nothing's different, nothing's different. Boom! Something's different, right? Whenever you see something different, and by something different, I mean a different external load, that's when you need a new function. So I ask you, how many functions do you need for this moment diagram? 3. One from here to here, one from here to here, one from here to here. That would be my answer to your question.
You mean the triangle or no? Yeah.
No, I'm saying that you need a single moment function to define the equation of the moment diagram from A to B. You need another equation to define it from here to here, and then another equation from here to here. Like what I'm saying is that moment diagram is probably, oh Lord. That moment diagram is going to look, don't take this to the bank, but that moment diagram is going to look something like this. It's going to look like that, like that, like that. Something like that. So 1, 2, 3 curves. So 1, 2, 3 functions. That's what I'm saying. Sound good? Going once. Going twice. Monday at 10 a.m. I'll pull up the code one more time. We'll see you then.